On tonight's show, we're going to do some fishing in Homosassa, and I'll also be talking propellers with Bob Musselman. We'll be looking at your emails and your pictures, and I've got a good Captain's Corner for you. Stay tuned because Hooked on Fishing starts right now.
Captain Bill Miller, third-generation Floridian and Grand Master Angler. He is hooked on fishing.
Oh, my!
That fish is bigger than I thought.
We got to go after this and we're going to get him. We may need some help with that, buddy.
Oh, he's coming in the boat.
I can see that coming.
Bob, the first thing, let's get started with props, is they have a measurement, and a prop would be like a 14-17. If somebody says that to you, and what is that measurement when they talk about props?
Well, the first number is the diameter, and the diameter is actually the hole in the water that the propeller makes. And
so that would be from there to there.
Right. And typically the way we measure it is the radius, because on this prop you can actually measure across here and get the diameter. But on like a 3-blade prop, we'd measure the radius from the center to the tip and multiply that by 2, and that gives you the diameter. This is a 13 3/4 diameter propeller. And the pitch on this propeller is 24, which means...
What is the pitch?
Well, the pitch...
Is that the angle here?
Well, people talk about degrees of pitch. It's not degrees of pitch, it's inches of pitch. And it is the theoretical distance the propeller would travel in one revolution. So this prop turns one whole time, it's going to go 24 inches through the water. That's not 100% because there is slip and there's drag. So if it's 24, it might go 20 inches. But it is an angle, but it is converted to inches. So you can't measure it. We use pitch gauges to measure an angle at a certain point, and then that converts it to pitch. But you can't actually just measure an angle and tell what the pitch is. We have gauges that do that.
What type of materials are props made out of these days?
Well, on outboards and stern drive props, you're seeing aluminum props, like this is an aluminum prop off of a 50 horsepower Mercury, and then stainless steel for outboards and stern drives also. And we tend to be seeing more stainless props these days as they become more sophisticated, and actually the prices have kind of come down on stainless steel props too.
Which are the tougher of the two materials, say if you happen to hit bottom, and which one will hold up the best?
Stainless steel definitely is it's way stronger than aluminum, but we typically recommend, like on a beginner boater, start off with aluminum prop, because that kind of is your first depth finder, you know.
Yeah, right.
So once you get good at boating, then you go to stainless steel, because if you hit something really hard with stainless steel, there's a better chance that you're going to do some damage to the lower unit. The other materials on inboard boats, you'll see bronze, which looks like brass, and then nickel aluminum bronze, or nibral, which is it's almost equivalent to stainless steel in terms of the difference between aluminum and stainless steel. Bronze and nibral, though nibral is not as hard as stainless steel. But you'll see that on bigger, faster, more expensive, big inboard boats.
When somebody buys a boat, Bob, we'll just say they're buying it for the first time, or maybe not to the first time. We'll talk about outboards, and they just assume that a standard prop comes with a 115 horse motor. But really the prop is tuned to the motor and the shape of the boat, or how do you figure out the exact tuning for that prop?
Well, the golden rule is that the motor is rated to turn a certain RPM at full throttle. So a 115 horsepower Yamaha is supposed to turn 5,000 to 5,500 at full throttle, just for example. So you want a prop on there that makes it turn between 5,000 and 5,500 at full throttle. And so you have to know what that range is, and then you have to know what the RPMs the prop is turning, so you have to have a tachometer. And within that range, you can have different props. That one prop might be a little better for hole shot, one might be a little better for top speed, so we can tune it within that range. But the bottom line is, even if you never run it at full throttle, a lot of people tell me, I never run it at full throttle, you need to prop it so that it will achieve full throttle for the motor to run properly.
All right, that was Bob Musselman, and some good information on prop. When you say hole shot, we hear a lot of people talk about a hole shot. What is a hole shot?
Well, hole shot is you're getting up on plane. I mean, that's how quickly you can get from dead stop to up on plane and running. So most people want to have pretty good hole shot. If you're fishing in the flats, you want to get up and running quickly. If you're pulling skiers, you want to get up and running quickly. And if you have poor hole shot, it's usually a sign that you've got the prop too much prop, too much diameter, too much pitch, and usually you'll find that your RPMs are low, and that means you're probably hurting your motor. Some boats just don't have a good hole shot just by their characteristics, but typically a bad hole shot is a sign that you've got, if it takes the whole lake to get up on plane, it means you probably have something wrong.
So the high-speed props would be mainly some of the muscle boats or the faster ski boats, or who uses that high-speed prop as opposed to one with a better hole shot?
Well, the cruisers typically, within that RPM range, a prop that turns high in the RPM range is going to have better hole shot. The prop turns faster, gets up quicker. Bass boat guy wants a prop like that. Okay, so if the range is say 55 to 6,000, he wants a prop that turns 6,000 because it'll get him up quicker. The guy that offshore fishes, he wants efficiency.
There you go.
So typically you will be in the lower end of the RPM range. You might prop a boat so it only turns 5,500 because at every RPM it's actually going a little faster at cruise because he's worried about the cruise speed. So at 3,000 RPMs, he's going to be going a little faster as opposed to having a better hole shot.
We were talking earlier about propellers, and Bob Musselman is our man at Admiral C&B Propellers. Now let's go back in the shop. We're going to see some real neat stuff. This is what happens when it gets too shallow or you hit something real hard. Bob, when that happens, the propeller is connected to the lower unit with a shaft, and when the propeller just stops dead in the water, does it strip the shaft and ruin the whole lower unit, or is there some sort of safety mechanism that keeps from destroying the whole lower unit?
Well, in the old days we had shear pins, which we really don't have anymore, but now we have a rubber bushing or a plastic sleeve typically that's in the propeller. And the primary thing that these things do is to absorb the torque of shifting so that every time you put that motor into gear, there's a clunk. And what this does is reduce that clunk so that the metal on metal damage all the way up to the power head doesn't happen. But these can also be slightly sacrificial, especially this one because it's plastic, it's a Delrin material. So you hit something hard, we get a lot of these in that are stripped. And if you strip it, it's real easy. You pop it out, pop a new one in, you can be on your way.
So this piece goes over the shaft. Those teeth align with the teeth in the shaft. Then this slides over this and goes into the prop.
And you can see that the prop has a square cavity that fits into.
So it would go in.
Other way. No, the other way. Actually, take the, there you go, right like that.
There we go.
Like that. And then that locks in that way.
Yeah.
And there's a couple different systems that are like this. This is Mercury's flow torque system. The Michigan XHS is exactly the same. Solus has a system. Johnson Evernew has a system that are all basically the same. They use just different materials. The old way of doing it, and we have a lot of props like that still, is a rubber hub like this. And this is actually pressed in to the propeller. You can see the rubber part of it here. And you can see it's much bigger. We use a cone to push it in, and then what will happen over time is this rubber, if you hit something really hard, will break loose, or the brass will break loose from this rubber piece. But that can also just happen over time. It usually happens 20 miles offshore when you least expect it. And with the new motors especially, we've seen a lot of problems, especially some of the four-strokes, because of the heat they generate and the torque, that they're melting these hubs. And that's actually what led Mercury to develop this system, because this is much more impervious to the heat and the horsepower. So there's a lot of people with four-stroke motors that have rubber hub props like this that we're switching to this because this will ruin your day. First off, it's likely not going to happen, but if it does, you pop it out, pop a new one in. To have this replaced, you have to bring it to a prop shop like us, and we have to press the old one out and press a new one in.
Okay. All right, well, there's some more interesting things about props, and in the next segment we're going to go back in the back, and you're going to be amazed at how they can take some of those props we were just looking at with the curled over blades on it, and how they can turn those things right back into brand new props. And it is really, really interesting. And you know, now's a good time when the fishing's not going real good and we got a lot of wind and they got a lot of time off the water, that you might want to take a look at your prop, maybe take it into your dealer or give them a call over at Admiral and take your prop in and let them recondition it. Reconditioning your prop will help you gain some RPMs, run your boat more efficiently than you have been. And if nothing else, it will give you the peace of mind that I've got the right prop on my boat and the prop's in good condition. That's a pretty important piece of equipment. If your prop goes out on your motor, it's going to be a long paddle home. We'll be right back with some more fishing. Stay with us. When you get ready to take the prop off, that nut on the back, is there a special wrench, or will any type of wrench, how do you get the nut off?
Well, there are wrenches that are made. This wrench is made for a lot of the V6 type motors, the bigger motors, and it's an inch and a 16th nut, or 28 millimeter nut. And this is a floating wrench. It also has a little thing here on the end where you can pull those tabs up. But it really, I think a lot of props get taken off with crescent wrenches, and if you have the right socket in your set, you can take it off with that. Whatever you can get in there and turn it. But these are nice to keep on the boat. They float. You can take it off real quick, put it back in your toolbox, and you're all set. So.
Okay.
Well, Bob, we've been talking about basically the outboard props, but you do work on great big ones.
Well, big inboard boats, cruisers, sport fishermen, mega yachts. We do a lot of that stuff too, and those can be propellers that are, 12 or 13 inches for on a ski boat that has a straight inboard, up to 50, 60 inches on a 100-foot mega yacht. So we do all that. The procedures are slightly different because they're more expensive propellers. We computer scan them, we high-speed balance them, but the work is very similar. It's all done by hand. We grind by hand, we pitch them by hand, but the measurement is just a little more sophisticated.
Bob, I see a computer getting involved in the process now. What does the computer do and how do you use it?
Well, the computer actually, all it does is do measurement for us. Everything we still do is done by hand. There's no robots or anything that's done mechanically to fix the propeller, but the computer allows us to make incredibly accurate measurements of the pitch of the propeller and then see what needs to be done. And it gives us it tells us exactly what the propeller looks like in 3 dimensions. Before, this all had to be done manually, and it took a long time, and it wasn't very accurate. This is quick, and it's incredibly accurate. So just about every inboard propeller, and that would be a prop that's on a straight shaft, as opposed to an outboard or a stern drive, which is on a spline shaft. Just about every inboard propeller, we computer scan, and then we also high-speed balance it because they operate usually in a high-speed operation.
And welcome back. There's the computer. Can't do anything these days without the computer, but we're going back in the shop right now. We're going back old school. You're going to see a lot of hammering and a lot of grinding, but that's what it takes to make your prop, refresh your prop or restore your prop as good as new and get it back running again for you. So let's go back in the shop, maybe get our hands dirty a little bit.
We're back here at the shop at Admiral C&B Propellers. And Bob, when a prop comes in that has damage, what's the first thing you do to it?
Well, the very first thing we do is we stamp a number on it so that we know that it's your prop. We get, some days we'll get 80, 100 propellers in here, so the first thing we do is we stamp them with a number that corresponds with an invoice number. And then we check them in. We check each propeller, we identify what it is, we see how much damage there is, and the number that we stamped on it, which is right there, will correspond with the whole day as it goes through the system and then eventually how it's billed. So we have somebody that identifies the propeller, sees what the damage is. Sometimes they'll ask for some sort of specific modification, and the foreman will decide what are we going to do to it to make it right.
Well, if it comes in and we'll say the edge of they hit a sandbar, hit a rock, and it's rolled over or dinged up the edge of the propeller, what do you do then?
Well, then we'll straighten it. We'll straighten it by hand on an anvil, and then we'll go to a pitch block. And we've got hundreds of pitch blocks that are shaped specifically for individual propellers and the size they are, and they'll be beat down to match the size of the propeller that it's supposed to be.
After the pitch block, what happens from here?
Well, then we take it to our grinders, and we get that prop there that we just saw
has some areas that need to be welded. So we'll get that area cleaned out so it's ready to weld, and then it'll go to the welders, and we'll fill in the material with actually new aluminum material. We don't use any lead filler or any sort of non-native material. We weld aluminum or stainless or bronze, whatever the propeller is, we weld that material back in. This is a prop that's been welded. You can see the welding has been, these areas that were missing, the prop's been straightened, the areas have been welded up. So now we will pattern the blades to the proper pattern, and we'll grind this off so that the propeller looks like a propeller again. After we grind the propeller and get the proper shape, then we finish the blades. If it has a cup in it, which is a little flare on the trailing edge, that's put in it by hand. And then the propeller, if it's painted propeller, it's sanded down smooth and then painted. If it's a stainless steel polished prop like this, we hand polish it back to the original high shine polish. And then they're done, ready to go out and do it again.
Yeah.
If I'm a guide, Bob, and I'm running every day, and I ding up my prop, I don't have time I have time to take it off. I don't have time to get it to you. Probably a good idea to have a spare prop, isn't it?
Well, yeah, it's just like your car. You should have a spare prop, and you should have a spare prop just like you should have a spare tire. And it should be a prop that's in pretty decent condition, because if it happens to you on a Saturday morning and you got trips the next 2 days, you don't have to limp around. You want to kind of be able to do the same thing. Same thing if you've got guests coming into town and it happens on a Saturday morning.
And welcome back. A spare prop's a good thing to have. I'll tell you what I did. The first time I dinged up my prop, I took it into Bob and I said, Bob, give me a brand new one, and I'm going to leave this one here and you fix it. And then I went home, put the prop on. I was going fishing the next day. And now if it ever happens, I don't even need to go to him. I can just pop that spare prop on, and when I get a chance, I'll run down there and get the one I've got that one reconfigured and reshaped. So spare prop's a good thing to have.